All right, let's jump right in. Today, we're cracking the code on what is, without a doubt, one of the most powerful and, let's be honest, sometimes confusing technologies of our time, artificial intelligence. You know that feeling? When you hear people throwing around terms like LLM, neural network, or overfitting, and you're just kind of nodding along? It can seriously feel like everyone else got a secret memo on a whole new language. Well, you are definitely not alone. And that's why we're here. Think of the next few minutes as your ultimate cheat sheet. We're basing this explainer on a fantastic guide from Virtualization Options LLC. They're a tech research and education group to give you the essential, no-fluff definitions you really need. To really get a handle on this, we're going to start with the big picture, and then, kind of like peeling an onion, we'll go one layer deeper at a time. So let's start at the very top with the big one, artificial intelligence itself. This is the giant umbrella term. It's the whole field of science dedicated to a single massive goal, building machines that can do things that usually require a human brain. You know, stuff like solving problems, learning, and making decisions. Okay, so how do we get a machine to actually do that? One of the main ways is through machine learning. This is a core part of AI. The key idea here is that instead of a programmer writing out rules for every single possibility, they feed the machine tons and tons of data and let it figure out the patterns for itself. It learns from experience. And if we go one layer deeper still, we hit deep learning. Think of this as machine learning on steroids. It uses something called neural networks that have lots of layers. That's where the deep part of the name comes from. Those layers let it learn ridiculously complex patterns, which is exactly why it's the magic behind things like your phone's facial recognition or your smart speaker understanding you. So, how does this whole learning thing really work in practice? Honestly, the best way to wrap your head around it is to think about it like you're in the kitchen following a recipe. Every AI recipe has three main parts. First, you've got the algorithm. That's your recipe, the set of instructions. Second, you need your ingredients. That's the training data, all the information you're going to feed it. The algorithm then cooks that data. And the result? The model. That's your finished dish, ready to be served and make predictions on new stuff you give it. Now, this cooking process can happen in a few different ways. Because just like us, machines have different teaching styles for how they learn from all that data. There are three big ones. First is supervised learning. Here, the AI gets an answer key. It's like studying with flashcards that already have the answers on the back. Then there's unsupervised learning. You just give the AI a mountain of unlabeled data, and it has to find the hidden patterns all by itself, kind of like being asked to organize a messy room. And finally, you have reinforcement learning. This is all about trial and error. The AI gets rewards for good moves and penalties for bad ones, just like how you'd train a dog with treats. But, and this is a big but, just because a machine is learning, it doesn't mean it's learning perfectly. There are some really common and pretty serious pitfalls you have to watch out for. First up, a huge one, bias. This is what happens when the ingredients, the training data, are skewed. If an AI is supposed to recognize faces, but you only trained it on pictures of one type of person, it's going to be really bad at recognizing anyone else. It basically learns and then amplifies our own real-world prejudices. Next is a funny one called overfitting. Imagine a student who doesn't learn the subject. They just memorize the answers to the practice test. They'll get a perfect score on that test, but the second you give them the real exam with slightly different questions, they completely bomb. That's an overfit model. It knows its training data perfectly, but it's useless on new problems. And, of course, there's the other side of the coin, underfitting. This is when the model is just too simple. It doesn't even learn the basic patterns from the training data. It's like the student who didn't study at all. It fails the practice test and the real exam. It just hasn't learned enough to be useful for anything. Okay, so let's shift gears and talk about the type of AI that has absolutely exploded into the mainstream, the kind of AI you've probably played with yourself. I'm talking about generative AI. What makes generative AI so special is right there in the name. It generates things. It creates brand new, original content that didn't exist before. We're talking about it writing an email for you, creating a photorealistic image, or even composing music. It's a creator, not just an analyst.
And the engine powering so many of these new chatbots, that would be the large language model, or LLM for short. These things are absolute beasts. They are sophisticated models trained on just mind-boggling amounts of text and code for all over the internet. That's how they get so good at understanding and generating language that feels convincingly human.
But what's actually happening under the hood when you type a question into one of those chat boxes? How does that conversation really work?
It's actually a pretty simple three-step dance. You start with your prompt. That's just what you type in. Then the AI does something called tokenization. It chops up your sentence into tiny pieces, words or even parts of words called tokens that it can process as numbers. And finally, based on those tokens and all its training, it generates its response.
But, and this is probably the most important warning for anyone using these tools, there's a massive risk called hallucination. This is when an AI spits out an answer that sounds totally confident and plausible, but is completely wrong. It's just made up. It will invent facts, cite sources that don't exist, and do it with such authority that it's easy to believe. This is a huge challenge. All of this naturally leads us to some pretty big questions about the future. So let's zoom out for a second and look at where AI is today and the rules of the road that are being built to guide where it goes tomorrow.
Right now, today, every single AI on the planet is what we call artificial narrow intelligence, or AIN. It means the AI is a master at one thing. It's an amazing chess player, or it's great at spotting spam. But it can't take that skill and apply it to anything else. The theoretical future, the stuff you see in movies, is called artificial general intelligence, or AGI. That would be an AI with human-like smarts that can learn and tackle pretty much any task. It's a goal, not a reality. Because this technology is getting so powerful, the field of AI ethics is absolutely crucial. Researchers are trying to set up rules for things like fairness to stop bias, transparency so we can understand why an AI made a decision, accountability so we know who's responsible when things go wrong, and safety to make sure these systems don't cause harm. But maybe the biggest challenge of all is alignment, making sure an AI's goals are actually in line with our human values.
And that leaves us with the final multi-trillion-dollar question. As these systems get smarter and more capable, moving from narrow tasks towards something more general, this problem of alignment becomes everything. How do we make sure we're building something that doesn't just do what we say, but does what we actually mean? That's the question that everyone in this field is racing to answer.